Good evening, everyone. This is Journal Club number 20. 18 will come later. But Journal Club number 20, Alex Kaelin will be presenting a paper entitled Clamping Cortisol and Testosterone Mitigates the Development of Insulin Resistance During Sleep Restriction in Men. That's a very good title, very specific, and it's a result. So take it away, Alex.
Okay. All right. Can everyone see my screen? All right. So, clamping cortisol and testosterone mitigates the development of insulin resistance during sleep restriction in men by Peter Y. Liu. So, a little context to this: sleep loss in men increases cortisol and decreases testosterone, and sleep restriction by 3 to 4 hours a night induces insulin resistance. So, in the study, they clamped cortisol and testosterone and determined the effect of insulin resistance. And then below that is a couple of abbreviations that they mentioned throughout the paper. So notably, HSCRP is high sensitivity C-reactive protein, and that's just a measurement of inflammation in the body, and that measurement can oftentimes help find a risk for heart disease or other cardiovascular diseases. Then we got HOMA IR, which is Homostatic Model Assessment for Insulin Resistance, which is just the method used to quantify the insulin resistant and beta cell function. The beta cell function is just the production and secretion of insulin from a cell. Then we got the IL-6, which is the interleukin 6, and it is a pro-inflammatory cytokine and an anti-inflammatory myokine. We got the MI, which is the Matsuda index. It's just another measure of insulin in the body, insulin sensitivity. The OGTT is another measure of the insulin, which is just orally. It's oral glucose test. The PYY is a peptide, and it's released from the colon in response to feeding. And then other ones are TNF, which is a gene that codes for a protein, and that protein then signals the regulation of immune response for cells. And then C-peptide AUG shows the insulin production. And then this first figure is kind of going over how they set up the experiment. So if anybody would like to volunteer to do it, that'd be great. If not, I'm going to just call on you. All right. I'm going to go with no takers. So, Colin Shepard, can you do this figure?
Yep. All right. So the top is just the placebo condition. So that's obviously just no effects. And then the clamp condition is just treated with testosterone or the cortisol over the different periods of days.
All right. Yeah. Thank you. Just the thing to add is they really stress the importance of the at-home base days. So it was consistent between both groups, and then the in-laboratory base day was also the same. And then they marked the times in which they took the test respectively. This table kind of just shows the demographics of the group. So the age is 33.26 on average, weight 79.16 kilograms, and then the race was 20% Asian, 20% African American, 55% Caucasian, 5% other. And then the sleep duration at home was 8 hours, and the sleep duration during the study varied, with stage 1 sleep 8.03% and stage 2 sleep 62.33%. And then figure 2, if anybody would like to volunteer to do that one. If not, I'm going to just call on someone.
Is it going to be another freshman? That'd be great. We're just going to torture the freshman.
All right, Nolan, are you able to do this for me?
Sure. So
Thank you.
basically it's just showing some of the differences in the effects of sleep restriction between the placebo group and the group that was treated. So the different ones are, levels of insulin sensitivity, the different like indexes. So just kind of showing the differences.
Perfect. Yeah, so the first table or the first chart on the left shows it without clamping. So it kind of shows just the difference between the baseline, which was regular sleep, and then the sleep restriction. And then for the Z-score, it's just the negative side, which confused me at first, was just showing that it was decreasing and not increasing. And then the one below that is just the sensitivity of insulin. And it shows the difference between the placebo and the clamp in relation to the baseline and the sleep restriction. So in both, you can see that the sleep restriction lessens the sensitivity to insulin, but those that are clamped, which is the clamping of testosterone and cortisone, are less affected than the placebo group. And then the two tests on the right are showing the same thing, just a different measurement of that. Any questions so far? All right. Thank you, Nolan. And then figure 3, if anybody would like to volunteer to do that one. Sophomores. Juniors. All right, Sean, can you do this for me?
One on me.
Yeah.
Be honest, I'm having a little bit of trouble with this one.
Gotcha. Anyone else want to take a shot at it?
I just want to orient us for a moment to the y-axis measurements in the first panel. Why aren't they labeling the panels with a letter? Like figure 3A is in the top left, figure 3B is in the top right. Is that too easy to understand? Because in addition to that, Lila.
Well, I was gonna say they kind of mentioned in the like description, like the whole like top left thing. So it's like similar to the letter matching thing. It just isn't as like clear.
Yeah, I don't know why you wouldn't just use letters, but look at the units they're using. What, like top left, what is that unit? Can anybody read that? It's kind of making my point. So if you read that as micro units per millimeter minute, micro units, because notice the milliliter is raised to the -1 power, which means it's actually a reciprocal, right? So it's micro units per milliliter times minutes. Am I reading that correctly? What kind of measurement is that? And then the next one is glucose measured in milligrams per deciliters times minutes. Now, glucose usually is measured in mgs per deciliter. If you have I don't think anybody in here is diabetic, but if you have a meter to read your blood glucose, that's actually the unit that's used. It's the only time really it's used for that you actually use a deciliter, right? We always talk about milliliters and liters, but we never really talk about that kind of in between thing called a deciliter. Like, what is a decimeter? a DM. Anybody ever use the unit of decimeter? Because you use centimeter, you use millimeter, you use meter, but there's also this thing called a decimeter, right? Right in between. I just find like that's weird how they did that. So now that I've given you enough time to not panic, can someone volunteer to do it? See what I did there? Uh-oh. All right. Go ahead, Alex. Keep it going.
Jack, you want to give it a try?
I'm not understanding this completely, but what I do see is
Oh my god, I was like, who the heck is Jackie? Do you go by Jackie?
no.
Did I say Jackie?
I don't believe you did. I thought you just said Jack.
Yeah, I think I just said Jack.
I heard Jackie, and I'm like, who's Jackie? I'm like, well, that's really bad if I don't know all the members of the AMI and there's a Jackie. But Jack, please, by all means.
Yeah, I don't understand this too well, but what I'm seeing is that the baseline kind of stays the same throughout everything, but the sleep restriction does change over time, it looks like. It looks like the first one, it usually is higher than the second one. I don't really understand the graph too much, but that's all I can really understand out of it.
Yeah, Lila, go ahead.
I think it's just kind of talking about the effects of like the treatment versus the placebo with different like diseases and things like that. And the little error bars just indicate how much it typically like deviates.
Mhm.
That's like the extent of what I know, but like that's like the basis, I think.
Yeah, that's great. So the columns on the left indicate the placebo trial or the placebo group, and then the columns on the right indicate those that were clamped for testosterone and cortisone. And the important thing to note is that the asterisk or significant differences. So like in order for the results to be important, it has to show significant difference. And so typically when P is less than 0.05, we consider that. But when it has 3 asterisks, it's even more significant, showing that they're even more highly correlated than suggested earlier. So
Hold on.
in particular,
Are there any people from my AP class right now who are in this room? Sophomores? I can't see the lists when you're hold on, presenting. I want to see close. I want to see the list. Show everyone. Sophomores, I recommend you come forward or I'm going to call. There are no sophomores in the room. Because I was just talking about that today with them. There's not a single sophomore. Okay. It's not more significant. It's either significant or it isn't. If there's more stars, you have more confidence in it, right?
okay.
You accept or reject. That's kind of a digital thing, right? It's like an on or an off. Something is significant or it's not. But your confidence in the fact that it's significant is indicated by the number of stars. Okay?
Gotcha.
But what test did they run for this particular thing? They ran a T test. Wow. Okay. If you look in, what is that? Page 3440. Figure 3 shows the effects of sleep restriction on other parameters of glucose metabolism. And then if you follow the statistics and you look in the parentheses, it says like T65 equals 5.64. T65 is 5.25. T63 is 2.52. Do any of you know if that's the right thing to do? Okay, if you've had me before and you've taken any course in which I've taught statistics, there should be an obvious problem with this figure. All right, juniors.
How about, are there more than one variation?
Yeah. Thank you, Miss
If
Liv.
there's more than one variation, can you run a t-test?
Effing no should be the answer, I believe. Do you guys understand that? A t-test is looking for a difference between two things. In that top left panel, where the t value is 5.64 for 65 degrees of freedom, how many comparisons did they run? That's easy. How many comparisons they ran is the brackets up at the top with the stars. How many did they run?
It's 3, right?
3. 3 comparisons. How many are you allowed to run with a t-test?
Just 1.
1. That is a totally inappropriate use of the t-test.
Unless they're trying to graph 3 separate t-tests on one graph.
They're not.
Which is then misleading. But
they're not. According to the paper. Are you looking at it, Miss Lee? Are you able to look at it yet, or are you still driving? I'm gonna assume she's driving. You
No, I'm not still driving, but I can't pull up the paper right now.
Well, so if you're going to do multiple comparisons, there are statistics for that are more appropriate. Anyone want to tell me what that statistic might be? Juniors. If you're not going to do a t-test because you want to do multiple comparisons, what are you going to use?
It's like the most common one, guys. It's like the most common. We see it all the time in these papers.
Sean?
Chi-square.
No. Oh my God, that was like the worst answer you possibly get. You're screwing with me, right?
That's like the least common one. Come on.
that's like that one's when you're counting things, you use a chi-square. No. What's the one you guys used on your labs? Come on. Oh my. Mary.
I remember talking about the Kruskal-Wallis last year.
Hey, I'll give you that. Okay, Kruskal-Wallis is the non-parametric version, right, for a multiple comparison. And if you're doing a parametric version, it's the what? Anybody else want to? Come on, it's that important that I'm actually taking time out to talk about it. We talked about it last week in Brendan's paper. What analysis did they run last week? And he's at a meet right now for fencing. Otherwise, he'd probably answer.
Done it T3.
No. That's the post hoc. I was actually going to mention that next. No, before that. Oh, come on. What is the main statistical test you run? The omnibus test for parametric. Mary is correct if it's a non-parametric thing. That's true.
Dr. Char, does it start with an A?
It does.
Does it then have an N?
Yes, it does. Oh my God.
Okay. And then an O?
Is it that ANOVA one?
It is the ANOVA. Thank you, Sarah and Miss Liff. It is analysis of variance. Last week, it was actually an analysis of covariance. And you may be like, why is he talking about this? Because you're going to use it like every lab you do. You're going to end up using some sort of statistical comparison. And you generally aren't just comparing two things. You're usually comparing more. And when you do that, if it's a parametric test you're running or you need to run, you're going to usually use an ANOVA. But Miss Liff probably has the same reaction as me. When you see them run the statistics wrong, as they just did, it makes me curl up like, uh-oh. Did they run all the rest of their statistics wrong also? Because a t-test is a parametric test. Anybody remember? You probably won't, but do anybody remember what the non-parametric version of a single comparison is between two things? Wilcox and Gibbs. It's like very rarely used, but very rarely by you guys. but you can. There is a test for non-parametric way of comparing things, Wilcox and Gibbs. And you're like, why do I need to know? Because this is you will, as this is a speech I gave today in AP. If you leave here knowing basic statistics, I win. Like that's biologists are notoriously bad at knowing how to do stats. I am not a statistician, but unfortunately, I've found I know way more about stats than 99% of biologists, and that is pathetic. Okay, because I'm not that good at it. If you guys are, if I'm proselytizing to you guys that you need to be really careful about stats, because the point of statistics is to figure out what is true. And if you do them wrong, do you figure out what's true? No. Which means you just wasted your time and the reader's time to tell us something that actually might not be real. You need to do the correct statistic. In this case, you cannot run multiple comparisons just using a t-test. You can't do it. And they do it persistently. So, okay, kind of since Mary brought up the Kruskal-Wallis, if you go back, Alex, can you go back to table 1? When I first glanced at this, I kind of was like, what are those numbers? Like, I've got age in years, and it says 33.26, then in parentheses, 6.44. What is that? 33.26 what? Like, what is that? Look at the bottom of the table.
It's the mean.
It's the mean. Are means the best representation of the data? If you shrugged your shoulders and say you don't know, that's the correct answer. We don't see the data. We don't know what it looks like. So what if they picked a bunch of 70-year-olds and 10-year-olds? What's the average age? It's going to be around like 33, right? Something like that. So you have this bimodal distribution, and the mean doesn't represent the data at all. But I can't tell because they did it like that. Now, that might be a minor thing, but here's where I'm really starting to get antsy. What's in the parentheses?
Standard deviation.
Okay, now go to the next figure. It's standard deviation. Go to the next figure. Okay. What are the error bars?
It's just standard deviation, right?
No.
Oh, standard error.
Yeah. Are those the same thing? Are they interchangeable? Sometimes, but like the inconsistency shows they have no, I may not be able to publish this video. They have no idea what they're doing. Okay. Like this is all over the place. And we haven't even gotten to the best part. Right, Alex? Right.
Yeah.
Okay. All right. I'm done. So you can go back to the figure. What was it? Figure 3? Is that where?
Yeah, we did that. So.
All right. So what's the point of this?
Real quick.
We couldn't make out what you said.
I was saying parametric versus non-parametric. Your meaning?
Anyone understand what she's saying? Did you just ask did you just ask for a description of the difference between parametric and non-parametric? Because you're breaking up.
From a freshman.
Oh no, we haven't gotten there. I haven't gotten there with any of the freshmen yet, so I don't know that they would know that. What the juniors should, and the seniors. You're breaking up real bad, so we really can't hear you very well. Okay, juniors, what's the difference between parametric and non-parametric? Okay, Bertone, I saw you just popped up on my screen. What's the difference between parametric and non-parametric?
I don't actually remember.
Sure you do.
Oh,
What's this?
the bell curve?
Yep. Normal distribution bell curve, right? So parametric data is usually it's like that. There's another way to tell though. The variance, how big the waveform is. In order to compare them, they need to be the same, right? You need to if a waveform looks like this, you can't compare it to a waveform that looks like that. Okay? There are no AP people here from AP Bio, Miss Liff, and she just left the meeting. I didn't even catch what it just popped up and then disappeared. Can be clear that they understand the difference between the two. Then from AP people, so the underclassmen can be clear that they understand the difference between the two. Yeah, I know AP people are here right now. They didn't make it. So, but Bertone just pretty much got it. But so one quick and dirty way, this isn't a great way to do it, but one quick and dirty way to tell if something is actually comparable is to look at its error bars. And if you have like a little error bar being compared to a really big error bar, then it's almost certainly not parametric. So you have to use a non-parametric test, which they didn't use. So if I look at something like, look in the bottom right panel for placebo, or for clamp, and they're comparing them to each other between baseline and sleep restriction. Are those things parametric? I would argue almost certainly not. And yet they ran a t-test on it. Totally inappropriate. I'm not going to be able to publish this video because I'm too harsh. They're going to send an assassin after me. Okay. So what was the point of this again? They did a bad job, but what was the point?
Yeah. So the point was showing that those that had sleep restriction typically produced more insulin, evident through the top left insulin AUC, which is just showing the insulin production, and then the glucose AUC, which is also showing the amount of glucose present. Okay, moving on to our next one. So in the paper, they actually messed this up. They referred to figure 4 using figure 5 and vice versa. So I believe this is the figure they were talking about when they referred to figure 4, right?
Guys, this is part of the fun of it, where you get to see people make mistakes, and mistakes are fine, but not in publication. Okay, you cannot be sloppy when you're writing papers, or especially putting your name on something. Like I've had people try to put my name as an author on stuff that I had nothing to do with, and I have to come down on them really hard because I do not want my name on something I did not do. And in this, and I certainly don't want my name on something that's done really poorly. And in this case, this is called figure 5. When they describe it in the paper, it's figure 4. That's really bad. All right, so what is this?
Yeah, so again, it just shows the placebo on the left column, the clamp on the right. The main takeaway from this one is that the dual clamp did not mute the clearance of insulin or the C-peptide AUC. So this kind of shows that for the insulin clearance, clamping it did not matter in regards to like difference to the placebo. And then the same thing is shown for the C-peptide AUC. And then, so we're going to go back to discuss the other figure because they messed that up.
They did a... Is Miss Liff still here? Miss Liff? No. Yes. Miss Liff, they did a Bonferroni correction on the t-test. It's like, what? I think they went into some sort of statistical software and just started clicking buttons like, what's this do? And then you just eventually got what they wanted to see, and sounds good. Let's go with it. And
do they have an editor?
Well, that's the this was published in April.
Oh, then no, COVID.
Which is like 9 months ago. right? Something like that. And in those 9 months, nobody has sent a notice to the editor to tell them, hey, in the publication, you need to switch figures 4 and 5 because you mislabeled them. And that, like, let's put blame where it's due. That really might actually not be the fault of the authors. However, when I publish a paper and I get what's called a proof copy, the copy that what it's going to look like as an edited PDF, I look at it and make sure that it's actually the way I intended it to be. I have actually had to send a correction to an editor for the eLife paper because they put something in wrong that we looked at our original version and we're like, this is not at all what we sent them, but they decided they would just like change something. And so we had to put a correction in. And it looks like we did some sloppy work when it was actually the journal. And in this case, none of the authors contacted them to go, hey, you switched our 2 figures. So I don't know, it's blame to go around here, but it's really sloppy, really bad. What kind of test did they run on this one? So we're looking in the text for figure 4. You need to actually look up where it says figure 5, and that tells you. So what do they run? Anybody? What type of test did they run? If they're giving you an F value instead of a T value, which test did they run? Sarah McTighe.
An ANOVA?
Correct. I don't know why they didn't do that before. And wait, which one did they do that on? They ran an ANOVA for IL-6. And that looks okay. Anything stand out is like, nah, man. No, they all look well. Okay, so look at heat shock CRP on the upper right. See the first comparison in the placebo? Do those 2 look like they have the same amount of error? I don't think so. Yet, what did they run? I don't know because they don't say specifically what they ran. And I also want to point out the figure legends are pretty bad. Not very descriptive. They don't really tell me what the conclusion of the figure is. All right, so who are you calling on?
If no one volunteers, I think I'm gonna go with Sarah.
Which Sarah
McTighe?
Okay.
I was overall confused with this one.
Because you thought that it wasn't talked about. There's one sentence about figure 4 in the paper. Figure 4
that's why I tried to look for something talking about it, and it just confused me more.
Right, because they switched them. Figure 4 shows that the dual clamp did not mute the clearance of insulin or C-peptide AUC. Is this about either of those things? No, because they labeled it incorrectly. Terrible.
So what it did show though is that there was no change with the sleep restriction and the dual clamp with the sleep restriction, and no significant effect on the treatment. In the on the HSCRP, there was no statistical significance between the 2, and that was the same for PYY placenta or placebo.
I should have done this earlier. Am I on? Yeah, I should have done this earlier, Alex. But can you explain the dual clamp, how it's done? Because I don't understand it. I actually don't understand it, that's why I should have asked earlier. But
yeah, let me.
Because it's just described as dual hormone clamp for cortisol and testosterone, which I understand. That's an interesting idea, but how do you actually do it?
I'm just checking the paper.
Like
That
I'm
was
reading.
also one of the things I was gonna say at the end. Is I would have liked if they provided, like, I guess, a diagram for how they did it or something to that regard.
Because I'm reading the methods.
Yeah.
And they do some hand waving. They go, by means of a novel dual hormonal clamp intervention to fix cortisol and testosterone exposure. So basically what they're saying, okay, is that they have some magic way. It's not magic. I'm sure there's a way to do it where they keep your level of testosterone and cortisol, which is a stress hormone. You keep them stable at all times. I just don't know how you do that. Like you have to, it's not an easy thing to measure cortisol and testosterone fast enough that you can respond by injecting it. Like I don't know how, this is an endocrinology and metabolism journal, so maybe they know better than me. So how do they do it?
Yeah, I didn't see where they said it like explicitly.
Did anybody see it? Because I don't see it. And it's interesting to call it a novel clamp and then not describe it. We came up with this amazing new thing. Boy, I wish you understood. Like, or don't you wish you understood? Yeah, I do. I wish I understood. Can you tell me how to do that?
There's a part where in the methods where it talks about the dual hormone clamp.
Oh, there it is. Okay, I just haven't gotten there. 800 million ketoconazole was administered as a loading dose. Interesting. Oh, that's interesting. I wouldn't have thought of that. I want you all to look at that paragraph on page 3439 about dual hormone clamp. It's a little scary, but it's an interesting way to do it. Like I was thinking that it had to be done live. And then I'd like somebody to explain it to the rest of us. I'll help you by saying that both cortisol and testosterone are steroids. Okay, they're both steroids. Okay, anybody want to explain what they did? Come on. You guys are torturing me.
Did they clamp the production of it and then?
So what do you mean clamp?
Inhibit with some other drug?
Completely. Yes. They shut it down with a drug called ketoconazole so that you're not producing any.
And then they just supplemented it, right?
With exactly the amount they wanted to show. Yes. Like so testosterone can be absorbed by the skin. Hence, about 10 years ago, low teeth, and I'm actually seeing it start to come back now because it went away for a while because it was stupid. But people were trying to sell testosterone as like a treatment for older men to get back their vivacious vitality. And there were different ways to do it. There was a drug called Axiron, which was like an underarm deodorant looking testosterone thing. Another one was called Androgel, which you put on your hands and then rub on your butt. And then there was this. Let's jump in here anytime if you can remember the stupid things that they can. There's obviously the needle, which is the typical way of doing it, but you can do the cortisol thing with an oral. Anyone see a problem with this? And it's an important one. It's a basic biology problem with the way they did this. Turn off steroid production, supplement you with something controlled. What's wrong with it? Are you finding this interesting, or are you being tortured too? Because I'm being tortured by your silence. Is this interesting?
I mean, I thought so.
Lila.
I didn't entirely hear it, but I feel like stopping something completely has negative side effects to it, kind of.
What type of major class of biochemical molecule are steroids? And then I'm going to come back to your point. Mary.
Lipids.
Lipids. Do humans have any other types of lipids? Can we all agree that people have like fat? Like fat is a thing, right? Remember we talked about, all of us have had this if we took honors bio. Steroids are soluble in fat. Hence the non-dairy snack mention, right? They're fat soluble. Depending on the fat content you have, which if I go back to table 1, there was a reason they did the BMI. They mentioned the BMI and they said that the standard deviation was 2.57. So 25 is pretty much on the upper end of average or normal, almost into overweight territory. To be at that upper end, you usually have somewhere around 20% body fat, right? Steroids are fat soluble. So if you're a man making testosterone, you're making it all the time and it's being absorbed by your fat, and adipose tissue itself becomes an endocrine gland. Like, you don't really think of fat as being a gland, but it kind of is. And so can you control the release of your already produced hormones by just giving you a drug that stops their future synthesis? No, you can't.
Would there be a way to, like, I guess, draw out the testosterone from the fat before clamping it entirely?
Not that I know of. That's why I'm looking at this going like, I don't know how they did this clamping thing. But then when you go and you read it, I was like, oh, I mean, in a human, they actually gave them a drug to shut down their production of steroids. Yeah, okay, theoretically. However, since the people in this study have a BMI of 25 plus or minus 2.5, they're at the upper level of normal, which means that they actually do have a significant amount of body fat. They have probably around 15 to 20% body fat, which means that that body fat is absorbing already produced hormones. And that means that's going to skew the whole study. Because if you're a man who has 40% body fat, you're going to have stored way more of that testosterone than someone with 15% body fat. Does that make sense? So you actually see hormonal imbalances can cause weight gain or weight loss, and it can also then reinforce itself. So if you have a hormonal imbalance causing you to gain weight, you then start storing up hormones that cause you to gain more weight. It's kind of a runaway, reinforcement, positive feedback loop. Make sense? Is that interesting?
Yeah.
I like look, we've gotten away with doing some pretty good papers lately. And I think that it's good to every once in a while have a paper that's not as good as the ones we've been doing before. Which I think you might understand my feelings about this right now. You probably guess what I think about it. All right, so go ahead and finish this awful figure.
We finished that one.
Oh, we did. Good. Great. 6.
And then the last figure, it just shows the effects of sleep restriction with placebo versus dual clamp treatment on cortisol, which is the left, and testosterone, which is the right. And then this mainly just shows that cortisol increased while testosterone decreased with clamping. And that was essentially the only takeaway from this figure. Any questions?
Yeah, why? What is this about? What's the point of this study?
Like this figure?
No, the study. You're coming to the end, right?
Yeah, I have the conclusions page.
Yeah.
Uh-oh.
Oh, there it is.
Okay. So fixing cortisol and testosterone exposure mitigates the development of insulin resistance and hyperinsulinemia, but not hyperglycemia, from sustained sleep restriction in men. And then the interplay between cortisol and testosterone may be important as a mechanism by which sleep restriction impairs metabolic health.
Do I dare speak for everyone and say who cares? I'm a circadian rhythms biologist. Who cares? Like, why is this? Why did you find this so interesting?
Mainly just because of the clamping and kind of how cortisol and testosterone, I guess, played a role in insulin. Like, I didn't know there was a connection there.
Should this have been published in the Journal of Clinical Endocrinology and Metabolism?
I mean, it's not that big of a journal.
No, it's not.
So, I mean, they messed up or not all of them, but they messed up a good amount of statistical tests. They messed up their reference to the figures. So, like, it wasn't well done, but, like, the journal itself isn't that large. I mean, I don't think it should have been published in general because it had all these mistakes. So,
its impact factor is 5.6, which is actually higher than scientific reports that we used last week. So it's like it's considered a better journal than the last two that we've used.
Dr. Shaw,
yes.
When you've had a paper that was published incorrectly,
Mm-hmm.
how quickly did it take for you to get notification of publication?
That day.
Right?
That day. They sent it. I immediately reviewed it. And like I had already seen a proof. I'd already approved the proof. And then they went and changed it and put the wrong thing up. So it got published and then needed to be corrected. Right. And I was really annoyed by that because that wasn't a mistake I made. If I made the mistake, I'd own it. But
and usually papers will print a correction or a reprint in the next publication.
If it's a print, this is an online only journal, I believe, which means you just instantly update the PDF.
You just update it.
Yeah. So that means
how does that?
I don't know.
And those of you who don't know, maybe you don't, maybe some of you do. Writing to publication is an intricate process. It's not like you write something and it gets reviewed and it gets posted. Like it gets reviewed multiple times.
Yep.
So for something to get the wrong statistical test, for the figures to get switched, to get swapped, and it gets reviewed by multiple different editors and reviewers that like don't know each other, blind reviewers that don't know each other. So for that to happen and get missed by all of those people, is really questionable.
Yeah. And the editors. I've been an editor for PNAS, and if I didn't, I would send a paper. If I thought a paper was just horrible to begin with and really sloppy, I wouldn't even review it. I'd say we're not interested in reviewing it, period. So send it away. Me as an editor making that decision, which is not really the way science should be done. But if it's so sloppy that it's obvious, then it's the editor is the first line of defense. But the editor let this go to review. It got reviewed, and then it still got published. So, but like Miss Liff, you made a good point. Is right in the middle of we're still right in the middle of COVID. So it's possible that some of our quality controls have suffered.
And mind you, the people who review papers, like the reviewers, not necessarily the editors, but the reviewers are just regular scientists like you and me, like Dr. Char.
Mm-hmm. Mm-hmm.
They're not actual paper reviewers. That's not what they do for a living. They're people who are just working their everyday life, get contacted by a publication, say, hey, we have this paper in whatever field that you might work similarly to. Would you review it?
Mm-hmm. It's my hope that the AMI is a vehicle to make you guys better than this. Is that fair? And but like, look, I'm not upset about this paper at all. I think that it's good to see that sometimes things slip through the cracks, and sometimes they're amazingly bad. Like you hear about the paper that was published in the Lancet that claimed that vaccines caused autism. People still cite that, and he made the data up. How about the time that the Riken Institute, a woman who was up for tenure, was so desperate to get a paper in a major sexy journal, Nature, that she sent a paper to Science. Science said no. She sent it to Nature. Nature was so interested in it, they said yes, sent it for review. It got rejected by all of the reviewers, and the editor still published it because he thought it was really, really important. Turns out she made the whole thing up. Take a cell, dip it in acid, turns into a stem cell. That's an extraordinary claim. Like, why aren't we just like ripping off cells and dipping them in stem cells so that we can cure cancer for ourselves right now? That's an extraordinary claim. And all the reviewers knew it and rejected it. It's Science and it Nature, and they still the editor made a mistake and still accepted it. And it was such a scandal that the Riken Institute in Japan still hasn't recovered. That was like, I want to say that was like 11 years ago, and they almost had to shut down because one scientist lied. Like, it's a big deal. You need to dot your I's, cross your T's, do a good job on these lab reports.
Like the autism one, that one.
Yeah.
That one is still so far reaching, and that individual has refuted their work multiple times, has publicly made statements saying that they misconstrued, they lied, they outright lied, they misconstrued data, they took data, they incorrectly presented it, and people still are taking it as truth.
Yeah. Right. So when in class I say, "Oh, I hear that vaccines cause autism, so you should avoid them," it's tongue in cheek. I'm kidding. That's because, can you prove a negative? Prove to me you're not a witch. Can you prove a negative? No. That's a good approach for anti-vaxxers to be like, you can't prove to me they don't cause autism. You're right. I could just show you overwhelming evidence in the most vulnerable populations possible, people with bad metabolic disorders, and I can show you that their incidence of autism are exactly the same as those populations, as the vaccinated ones. So you're talking about immunocompromised, metabolic disorder kids, half and half, split them in half, vaccinated versus non-vaccinated, same rates of autism. So that's a null, that you fail to reject the null hypothesis. Does it prove that they don't? No. It's just like overwhelming evidence. Get off it. At some point you got to move on. Especially when we find when they actually found out that he literally sat there pen on paper making data up because he had a feeling. He had a feeling that it caused autism. Anywho, yeah, Alex, you want to add anything?
No.
Did you choose the paper because you're feeling like self-conscious about testosterone?
No. I saw it and I thought it was interesting.
Mom, is he feeling self-conscious about testosterone?
No, he's good.
Okay. Well, I'm about to turn 40. I'm feeling self-conscious about testosterone. I hear you, Miss Liff. Have you seen that they actually started advertising it again? Like for 10 years, it went away after everybody was like, "Oh my God, people are having birth defects because of testosterone treatment," and so it sort of like went away.
And I don't pay attention to testosterone treatments. Actually, it's not like my forte of things to watch for.
You just slammed me on that one. That was mean. Wow. One last thing I wanted to mention. Very early on, when Alex was going over the abbreviations and he talked about oral glucose tolerance test. If any of you are near your mother right now, ask her if she had one when she was pregnant. Things to look forward to, ladies. Okay. Or Miss Liff, have you ever had an oral glucose tolerance test?
No.
Oh, things to look forward to, ladies. Delicious. Ask your mom; they'll tell you. Okay, it's a kind of a thing that's done in moderate to risky pregnancies. So
really excited! I get to do a salivary cortisol test. So excited!
When's that?
Whenever I'm not on my steroidal inhaler.
All right. Anyone want to add anything else? How did we want to end this, Alex? We wanted to ask.
Not good. Not as interesting as I thought it was going to be.
Okay, but it is important, people, that you not be tortured and therefore torture me in return. Okay. Journal Club is something you should look forward to. Okay, it's something where it's not like extra tons of work, but it's something where you keep abreast of the best new research that's out there. And when we choose a paper that fails to interest you, you need to be forthright and tell us, so that you can inspire next week's person to pick something in a field or genre that you're interested, so we can have fun with it. Okay, but it's part of the reason we do this. You're not going to become a scientist if you don't find it fun. So I don't know how you felt about it. I won't ask, but about that paper. But if you have some ideas, share them with it. Who's the next person going? Do we know? I don't remember. We don't know. Okay, well, good job, Alex. Yay. Yay. All right. See you guys later. Thanks, Alex.
See ya.
Thank you.
Okay, bye.
Thank you.